Going to learn a new term, calorimeter. What's this calorimeter? So we cannot say how much heat it absorbed, right? How much heat it gained or lost. We cannot know how much heat it is gained. So to measure a heat, we need a unit, that is unit of heat, that is joule, and commonly it was calorie. And to measure the amount of heat in a physical or chemical process. So physical, what's that physical? Or outer appearance, shape, color. So what is a physical change here? We already know that change in the outer texture, that's called physical changes. Chemical changes, changes in the molecules or their composition is called chemical changes. So how heat is involved in the physical or chemical process? To measure that, we use the term calorimeter, right? Here another topic, we already know that temperature. We already discussed that when we apply heat, there will be a rise in temperature. What's the temperature? Measure of warmness and coldness, right? What is the rise of temperature? See, if you place a hot cup of coffee, yes, it is hot, so there is some amount of heat is there, right? If you place that hot cup in a stove again, what happens? It will be hot even more. So what's that exactly happening there? The temperature rises. How temperature rises? The molecules inside that coffee will be vibrating very fast when you apply heat. So that causes temperature, right? Usually how temperature is measured? In Celsius, Fahrenheit and Kelvin, right? Most commonly used is Kelvin, and we know that unit of heat is joule and commonly used is calorie. So here the relation between calorie and joule is given. 1 calorie is equal to 4.186 joule. And the next topic is heat capacity. What's that heat capacity? Let me see what's that heat capacity. To heat a substance by one temperature, right? To heat a substance by one temperature degree Celsius or 1 Kelvin, how much amount of heat is required? That is called heat capacity. So I'll repeat again. The amount of heat energy required by a substance to rise its temperature by 1 degree Celsius or 1 Kelvin, that is called heat capacity. That was mentioned in the formula basis, amount of heat required, heat energy required, that is denoted by Q, and rise in temperature. And what's the delta? The triangle? Change. The triangle symbol denotes change. So from 30 degree to it rises to 40 degree. So how much temperature is changed? 10, right? From 30 to 40 the difference is 10. So that is rise in temperature, and that is denoted by small triangle, that is called change. And the unit of heat capacity is, what is unit of heat is, we already discussed, joule. And for temperature, what's that? For temperature it is Kelvin. So it is measured as joule Kelvin. So joule divided by Kelvin, which can be replaced like joule Kelvin inverse. When it comes to upside, when it is in the denominator, and if you want to go to the numerator, you should use -1 symbol. If you refer your book page number 39, you will be seeing that J K inverse. So -1 means inverse, right? For heat it is unit is joule denoted by J. For rise in temperature it is Kelvin. So rise in temperature is in the denominator. If you want to put it in the numerator, you should use one more symbol, that is -1. Right? Have you understood this? And next is specific heat. Next one is specific heat. See, same as heat capacity, but the only difference is in the denominator you have one extra term, that is mass. Mass means weight of a substance. So from this we can define the specific heat capacity. That is, specific heat capacity of a substance is defined as amount of heat required to rise the temperature of 1 kilogram of substance by 1 degree Celsius. So here in heat capacity, whatever it may be the substance, we don't mention the weight of the substance. In specific heat capacity it is mentioned as 1 kilogram. That was included in the formula. And here we have three terms. So in your writing the unit, three terms must be there. So from the formula you should know the units. So here three units will be there. One is, what's the unit of heat? It is joule. Unit of mass is kilogram, and rise in temperature is Kelvin. So here two terms are in the denominator, right? What are the two terms? Kg, that is kilogram, and Kelvin. So if you refer page number 40, three terms will be there: J, kilogram inverse, and Kelvin inverse.